Hello students, today we will discuss about our so many instruments that is called as a measuring devices to measure currents and voltages. So you are aware about so many instruments. So we are discussing about one instrument that is called as a galvanometer. So this is not a new instrument for you. You may have seen such instrument in your physics lab. So first of all, we are just aware about galvanometer. Galvanometer is an instrument which is used to measure both current and voltages. So it is used to measure current and voltage. The instrument which is used to measure current is called as a ammeter. Yes, in market direct ammeters are also there, but we are using galvanometer to be used as a both current measuring device and voltage measuring device. So voltage has been measured with the help of one instrument which is called as a voltmeter. So first of all, very primitive questions in so many practical exams people are asking that how you can connect your ammeter, which is actually indirectly galvanometer, to be used as current measuring device, how you can correct it. So whenever you are using your ammeter, always connect this one in series with your measuring component or measuring points. Whenever you want to measure voltage or our galvanometer, which is being used as a voltmeter, you must to connect with your points. It is called as a with parallel connection. So such are the primitive questions. What are those precautions whenever you are making your ammeter or making your voltmeter or measuring current or voltage you will take? So after this theorem you will be capable enough to answer such type of questions. But first of all, let's see primitive connections of our galvanometer. Galvanometer is a very primitive device. Let's say we have two nodes of a magnet or magnet north pole and south pole, and there is one cylindrical type of arrangement, and which has been having number of tons of a coil has been wounded around it, and that is called as our one node or pointer, which is indicating our numbers on a scale. So this pointer or coil is connected with the one wire in the terms of a current. Whenever current is passing through it, it will be giving that contraction and expansion of this coil, and contraction and expansion will lead to the change in this needle part, and we can calibrate the amount of current or voltage which is passing through it. Yes, there are so many precautions we have to take about, and then we will discuss about it, and we will also discuss about how it has been made. It requires some of the basic technical knowledge to make an ammeter, galvanometer or voltmeter. So first of all, our formula which we have learned, that is called as a tau is equals to our beta, and that is our primitive expression. You are aware about that spring constant because we have a coil which is in terms of a spring. So our force or angular force tau having relationship of k5. So you are aware about this expression in your 11th science. It is called as our spring constant value. So I am just comparing equation number 1 with equation number 2. I may have k5 is equals to beta. This is the expression which I am in a need of it. So I am just putting what k5 or b or I or n denotes about. So I am putting their values, what actually tau b and everything. K is called as our spring constant or force constant, which depends on the type of the material, number of the tons. 5 is called as our sensitivity, which we are supposed to calculate about. Now we have a B, that is called as our magnetic field. I is called as our electric current. N is called as a number of tons wounded on our circular rod or circular part or materials area, which has been having our cylindrical nature. It's the area and number of tons of material which has been wounded on this such type of cylindrical part we have. Now we are utilizing this formula in a two type of terms. This expression will be utilized as a two type of terms. So first of all, I am just using that galvanometer is being used as measuring device. So first of all, it has been used to measure current and then voltage. So I am using that. It has been used as an ammeter, or it is called as a voltmeter. If I want to utilize this one as an instrument to measure my current as an emitter, I am using the same formula, but converting this one in a different manner. So first of all, I am mentioning K5 or 5K is equals to BINA. So I am just converting this expression, that is giving me 5 by A is equals to BNA divided by K. This expression, this formula phi upon I, this is the equation which is called as a sensitivity of an ammeter. Now the same equation I am utilizing, 5K is equals to BINA, but I want to convert this formula. So 5, instead of I am aware about my formula V by R, it is called as a Ohm's constant. So V by R is equals to BNA divided by K. So this is called as a 5 by V is equals to BNA by KR, and this is called as my sensitivity of a voltmeter. So this is my sensitivity of a voltmeter. So right now you are aware about the sensitivity of both my voltmeter and an ammeter. What is sensitivity? It is called as a very minor amount of current or voltage which is passing through our instrument, and what number of rotation, what number of sensitivity it must contain, we can calculate by such type of instrument, such type of mathematical notation calculation. We can find it out. The ratio of a phi to I, sensitivity by current, is called as a BNA by K. Actually phi is called as a fluctuation angle. Phi by V is called as our sensitivity of voltmeter. It is called as a sensitivity divided by our voltage, or you can say that our flux phi. Basically in future you will use such type of word phi, flux. So phi is actually an angle, because we are aware about our formula tau equals to beta sine theta. So K into phi is called as our angle as well. So angle divided by voltage is called as a BNA by KR, is called as our sensitivity of our voltmeter. So very first thing clear to you that whenever galvanometer has been used as a current or voltage meter or voltmeter, you cannot use directly. You have to take some of the precaution or how it has been connected. So first of all, we have just seen that how it is connected, series and parallel, and what are those formulas. It's a sensitivity. First of all, we have to calibrate. Even though sensitivity is not properly calibrated, even smaller amount of current will pass out, our needle will show full deflection, and it is not getting any movement because of our current is higher. Magnetic field produced over here is higher, so angle will be full. It is showing full angle even though current is passing, and this coil will be completely burnt. That is how you are damaging your instruments. So whenever you are using galvanometer or galvanometer as a current measuring device or voltage measuring device, be careful about its sensitivity. First of all, calibrate it. If it has been already calibrated, then just go for such type of series and parallel combinations. Now there are other precautions you can also take about. So I'm just taking that a title that you cannot directly connect it. There are some of the precautions. So precautions are there. Whether you are using it, you cannot directly convert it. So first of all, galvanometer is been used as an ammeter, and next one is called as a galvanometer is been used as a voltmeter. So these are the primitive rules we have to follow. The very first thing I am drawing a structure. Let's say I'm just saying that this is my galvanometer, and this is its internal resistance. You can also connect external resistance as well. But whenever you are measuring your current, ideally advisable is that don't use extra resistances. So I am just applying current I. As per my Kirchhoff's law, I am getting the same amount of current. Now you can apply Thevenin theorem. As per Thevenin theorem, the amount of voltage which has been over between point X and point Y, both are equal. So I am using such type of data and mentioning it. So first of all, I am just using that S is called as a shunt. It is called as a little resistance or less resistance. Sometimes they are asking that what is the unit of a shunt. It is called as a ohm. It contains the same dimensional configuration as our resistances. Our Rg is called as a internal resistance of galvanometer, or you can say external resistance as well. It is up to you. Capital G is called as a galvanometer's resistance. You are aware about every instrument contains a little bit amount of resistances, so there is no harm into it, and it is how you can just say that. So from figure I'm applying Thevenin theorem. So our voltage at point X and voltage at point Y both are equal. So I can just say that amount of current which is entering in this much part is called as Ig, and current which is left it is called as I minus Ig. So current which is called as Ig into G, and Rg is already there inside. So I can just say that Ig into G dash is equals to, I can just say that left part is called as I minus Ig into S. I am mentioning that G dash is called as equivalent resistance of capital G, which is itself resistance, Rg itself resistance. It is called as a capital G plus Rg. So it would be quite clear for you. So now I can have Ig G dash divided by I minus Ig is equals to S. This is the equation of shunt. With the help of this, you can calculate the amount of resistance which has been connected over here. You cannot use whichever resistance you like directly. It may harm your measurement because you are taking higher amount of resistance, so it may give you that wrong impression, wrong amount of current. So always with the help of such type of their instrument, you can calculate shunt value, and then that value whichever you are getting, place over here the amount of current which you are supposed to measure. Let's say I have my capacity of current which is passing is called as a 20 ampere. So put over 20 ampere over here. And the instrument which will show your Ig amount of current is there, I minus Ig is there. After calculation of S, you can just find it out or use your galvanometer as an ammeter. Without that, you are damaging your instrument. Another thing which I want to just show you is that galvanometer can be utilized as a voltmeter, but there are some of the precautions. So first of all, I am just connecting again capital G, and there is another resistance I am just mentioning is that Rg, one external resistance which I am connecting over here, and let's say I am connecting a voltmeter over here, or it has been connected as a voltage. So you are aware that those data which we have already discussed, current I is passing from here, so same current will be passing over here, same current over here, same here, and same current will come out from here. So we are aware about our Kirchhoff's second law, V equals to V1 plus V2. So I am just using this notation, V is equals to current I into G dash, and same amount of current into I. I am just mentioning that G dash is called as my resistance of my galvanometer, and Rg is the internal resistance which I have already placed over here. So my equation or R value I have to calculate. So R equals to V minus Ig dash divided by I. So I may say that R is equals to V by I minus Ig dash. So this is the value of resistance which I have to connect over here. And after this calculation, you can use your galvanometer, which has been used as a voltmeter. Without that, you cannot. So I'm putting one Mentos moment for you, so you can just calibrate this thing. Whether you are using as a voltmeter and whether you are using it as an ammeter, so you can just use such type of word. Always connect a resistance R which is in series, resistance R, which is in series with our galvanometer. And always connect your shunt in parallel. So after this such type of connection, you are just practically converting your galvanometer into ammeter, and after calculation you can place these values and you are in a proper position to calculate all those data. So previously I have asked you the question that galvanometer or voltmeter cannot be, or galvanometer cannot be directly utilized as a ammeter and voltmeter. Why? So now answer is there already. There are 2 points. First of all, we have to calibrate its sensitivity, and second thing is that we have to, if we want to use galvanometer as an ammeter, we have to connect or convert or connect one small shunt. After calculating it and placing it, you can just go for the conversion of galvanometer as an ammeter, and after calculation of your capital R, you will be in the position to measure what amount of voltage it will be capable enough to handle, or galvanometer will show. So these are the practical questions in practical exams and theoretical exams people are asking, so be careful. This is the equation of your sensitivity galvanometers. These are the sensitivities of a galvanometer as an ammeter, and it is called the sensitivity of a voltmeter. And these are the points of its resistances. So this is the end of your chapter number 4 theoretically. Now we will discuss about its examples in next onward clips. Thank you.